Start recording. Okay. And we're going to give a moment for people to join the panel. So bear with us. So we see everybody trickling in. Okay. Well, thank you everybody for joining us here at LRVS EMEA edition. And I'm really thrilled to be able to moderate this panel of industry experts. And this discussion is going to be about how can machine learning impact maintenance schedules. So if we can real quick, maybe 30 seconds each, do an introduction for the audience, for yourself. So Alexandra, I'll let you go first because you're top of my list there.
Yes, top of mind, maybe also. But I'm Alexandra Gunderson. I am an engineer by background. Started off my career as a mechanical analysis engineer working in oil and gas and nuclear sectors before making the switch to the world of data science about 7 years ago. So worked in a Norwegian startup for large oil and gas customers and manufacturing sector, delivering predictive maintenance solutions, anomaly detection solutions, and some condition monitoring solutions. Really looking forward to the panel today and sharing some of my thoughts on how AI can impact maintenance.
Awesome. Thank you, Alexandra. And Erik, yep.
Wonderful. Thanks. I'm Erik. I'm business director for a company called Distance. We are a software and technology company. However, we believe that technology only comes in second and services come first. These are merely tools to carry the service with. And this is where my role comes in. I build partnerships with service companies, with OEMs, with the service branch, MROs, etc. All of whom would be companies that deliver condition monitoring services. We help them grow their business and grow reliability at their customers.
Excellent. Thanks, Erik. Mika?
Good afternoon to everybody. My name is Mika Perttula. I'm the CEO and co-founder of Fluid Intelligence. And we provide oil performance monitoring services to our industrial customers on a wide range. And we also develop our oil performance optimization and oil data management service called Fluid. And our main objective is always to come up with the solutions to our customers' problems, and we aim to maximize the life cycle of the industrial fluids, maximize the reliability, and also parallel minimize the CO2 emissions and cost for our customers. So that's briefly us. Thanks.
Excellent. Thanks, Mika. And Matthew.
Oh, thanks, Josh. Good afternoon to everyone. My name's Matthew Moore. I've been a subject matter expert in condition monitoring and involved in condition-based maintenance for going for about 30 years now. I'm now starting out on my own as a consultant and trainer in the industry.
Fantastic. So this brain trust that we bring here in terms of condition monitoring and sort of that next level of machine learning, right? And there's so much news about AI and generative AI and language learning models. How do we see machine learning, specifically machine learning, affecting maintenance practices, right? So we talk about extending intervals, right? But just in general, maintenance practices. And Matthew, do you want to take that one first?
Okay, well, obviously with machine learning, what you're looking at is kind of historical information to predict the future. So it very much lends itself towards predictive maintenance and condition monitoring. One of the problems we've always had with like condition monitoring, for example, is knowing when a machine's going to fail. I don't think machine learning is really going to define that much better, because we would need all the machines to fail for it to have enough information to really know the failure point. However, it will provide us much more information with regards to that. And where it could really add value is knowing how long it takes to repair equipment, what parts you need, historically, how long they take to come in. I think in the condition-based maintenance side, there's really a lot to gain from what it will know about your supply chain and how to best optimize your maintenance and plan and give a timeline for a lead time to repair.
So almost like tying into your say SAP system and the ability to order parts
Exactly
in advance, and so just in time, lean maintenance maybe, right? Okay, what's your take on that, Erik?
I agree with Matthew there, because I think all those machines, they hold tons of information, and retrieving those data, if well done, it gives you access to learnings, and not only for that particular machine, but for and from thousands of machines like it. And the more we know, the more we compare and learn, and this affects, of course, the way we keep the machines healthy. Instead of just looking for a failure, just to prevent them by treating them well. And I think those learnings are important for the asset owner, and they are important for the ones that service the machines and for OEMs to better design, right? And I also think that machine learning, it can really help us as a tool, but we also have to make that information understandable for all of those stakeholders, because, well, I don't understand everything that our wizards are doing, but that is their job, right? But it's also their job to make it so that I understand just enough. Does that answer your question a bit, Joyce?
To not overcomplicate things, right? And
yes, to not overcomplicate, indeed. Yeah.
Alexandra, I think I saw a smirk there. Maybe some response to it.
Oh, no, not the smirk. I agree with what everybody is saying. So I think, predictive maintenance is of course, a very clear opportunity for where machine learning can be used and to help to predict failures. But then, like Matthew was saying, to figure out when things are going to fail, how much time, how can you improve the maintenance that you're performing. But I think that there's also other opportunities for other sort of data sources to be used in addition to like the sensors, like all of the text and PDFs and documents, right, that we have. And that's really a unique opportunity for like generative AI to be used to make maintenance specialists more efficient, right? To sift through the tons and tons of data and find examples that are like previous maintenance events that were similar to the one that had just occurred, and then also looking through like the logs and the reports to come with suggestions or potential actions that had been performed previously. So that's more of like on the text side of things and document parsing. And then there's also a lot of opportunity for things like robotics and to be doing like unsupervised maintenance, unsupervised sort of operator rounds and things like that. And that contains some elements of machine learning as well. So I think that there's so many different ways to use the data and machine learning to make maintenance specialists' lives a little bit easier.
Yes. Yeah.
And Mika, your take on this?
Yeah, I think almost all has been said already. No, basically, what basically Matthew was raising initially, that basically we don't basically have maybe all the data yet of all the different failure modes and so on. Then on the other end is basically that Alexandra was highlighting that how can we use all the like complementing data, like textual data and so on. But I think that from our perspective, of course, we mainly focus on optimizing fluid performance. We want to see and use the machine learning so that we're basically not seeing the maintenance events that frequently, but really extend the life cycle of the fluids and at least prevent like that many downtimes and breaks from at least from fluids perspective. But maybe one thing to raise here is really the data that is the foundation for all the analytics. So of course we are able to use like generative AI and so on to gather and go through a lot of different data sets. But when it comes to like sensor data or lab data, and then basically the history of the maintenance. So many times what we've seen that the data quality is not there yet, so that we could really do very holistic and far-reaching analysis. So many times a lot of time that where we spend time is really to work with the customer's data and also our data. But well, we are seeing that improving all the time. So hopefully in the near future we are in a situation where we have the foundation in a better shape and we can really grasp all the benefits that machine learning and AI has to offer for us.
So and I was in aerospace decades ago, right before this, and there was a sort of a knowledge base. One of these engine OEMs put together where all their field service engineers had to put cards in, and so they built this. You know, if this happens, then here are 10 possibilities, right? And then as you troubleshoot, it sort of narrows it down, right? So that's like the standard, right? It's this knowledge base, and then you know, you put the symptoms in and you narrow it down. Do we today have any examples of true machine learning where this knowledge base is now being used in this AI realm, where it can do these calculations with less human interaction? I know that's almost a loaded question, and whoever wants to take that up, or if you're seeing, are we approaching that in a way, right? In a short period of time? Erik, you're nodding, so I'm gonna pick on you and toss that one.
Yeah,
to
well, we're not here to advertise, of course. So I got to choose my wording carefully. I would say, but this is what we are achieving and what we keep achieving. But it is the way we see it is the AI sits on top of data retrieval, of data handling, of automated data analysis, as in our case. And it basically it's just there to complement it and to shorten the workload even more, providing workflow for users, for basically for everyone who's working with it. And that is where it becomes very important. It is AI, and with that machine learning, it is set up to help us, to work for us and with us, not to eliminate our roles. Our roles still are needed, and you still need an expert to evaluate what such a machine spits out, right? You have to evaluate this, because none of those models will ever be always right. We need the expert to look at it.
Excellent.
And also implement those
Yes.
actions and recommendations, and that basically is what we've also like learned past few years, that it really needs to, like, monitoring something is or even like analyzing something it's on like halfway, and where we put a lot of emphasis is really to how far we can take the model, so that we are like providing really intelligent and like actionable advice for our customers based on the analysis. But yeah, I would also agree with like Erik that the humans are needed for quite some time still in this process, and see and validate how smart our machines are that we are like teaching. But maybe still linking back to this data topic is that what we've seen also from like food's perspective, if you take on like lab data, it seems that many times it could be like a cost reason or some other reason that one time you're having like a really holistic like a lab data analysis of your machine, next time you're having a much more concise, and next time you're again have like this holistic. So there's some work to do, and definitely need for humans to oversee the whole process, and then how do you really implement the actions and then bring it back to these models. But yeah, I think that we've scratched the surface, and there's much to do, but also much to gain.
Mm-hmm.
Thanks for that, Mika. So we have a question coming in the Q&A, essentially saying, is machine learning theory at this moment, simulation, or is it a practical matter on machinery today, right? So I guess it sort of goes into the earlier question of, where are we today versus what's happening in industry, right? Or what can happen. And Matthew, do you want to?
I think one of the challenges we've probably got at the moment is our legacy systems were never designed with AI in mind. So we've got loads and loads of data and it's not categorized. Mm-hmm. One of the advantages of AI machine learning is it will help us categorize that historical information and make it more useful going forwards. But what we're also going to learn going forwards is how to make our data better controlled in the first place, suitable for using in these AI systems. And yeah, with the machine learning, the practicalities of it, it's already here. It's here today. It's only going to get better. And the theoretical side, providing you involve your maintenance people, all your people on the site that understand how things are, and you put some of the human aspects into it, then it will be very powerful. If it's only designed as a data system by software people and not by engineers, then it will probably struggle to deliver what the expectations are.
Mm-hmm. Yeah, very true.
Alexandra, any further comments on that?
Yeah, so I mean, I guess so when it comes to like what machine learning is if it's theory or if it's able to be implemented. I mean, there's so many examples, right, of machine learning being used in practice, especially like on the consumer side of things. I think, like Matthew mentions, in the industrial aspect, like there's so many challenges or there's so many sort of different bottlenecks, right, that you have to like get through in order to get a machine learning algorithm used in practice. And I mean, one of them is just like data connectivity. The other is being able to put a algorithm like that on, what system do you put it? Do you put it in the cloud, or do you put it as close to the data source as possible? And then also like how are the predictions or what the machine learning model is detecting or classifying or predicting, how is that going to be used, right? So it needs to be used in order for it to be real. And I think a lot of those sort of challenges need to be addressed before we can see widespread adoption. Matthew also mentioned in the beginning, when one of the first questions about the importance of having like standard data across your equipment. And of course, we don't always have that, right? Like in order to actually build fleet-wide machine learning models, which is what you need to do if you're going to have enough like statistical evidence to build a robust machine learning model, you need to be able to compare apples to apples. And that's like a data categorization, data labeling problem. And there just aren't really a ton of great tools for doing that. And it's also not really the fun work, right? So it's a little bit tedious. It's a lot of data to go through, and we need digital tools in order to do that. And maybe also sort of circling back to the thing that you mentioned, Josh, about like the putting the rules in place. So I believe very strongly that rules and theory should be included in the definition of condition monitoring algorithms. I don't think that you should just put like data in and hope that your machine learning algorithm, however robust, is going to come up with the best predictions. I think that it's important to combine the best of both worlds. And to answer the question that you had before about if that's being done in practice, that is part of the work that we're doing here on a daily basis, is building that sort of like knowledge base and that knowledge graph so that you can connect data from different sources, put in place rules where necessary, and make like machine learning algorithms available through sort of every step of the way, whether it's like on a document parsing level or looking at images or looking at time series, so that it's just building your knowledge graph in a more robust way so that it's accessible to the expert. So I think that contextualization is a really important part if we're going to have scaled AI.
Mm.
That's a good point. And sort of this other question that's out there about data analysis is part of machine learning, but there's so many variables, right? And what you discussed, Alexandra, about we don't have a standardized system to A, measure certain things, right? And B, collect, right, the certain things. And where it's hosted is another aspect. But collecting all these variable data where there's industry specific on fluid analysis, there's industry specific on vibration, there's industry specific, siloed, these sort of siloed things, even things as the outside environment, right? So if operating in the desert, operating in Antarctica, operating right in windy conditions, dusty conditions. So all these variables, and how do you measure those things or collect that data and then be smart enough, right? And this is where the human intervention comes. It's like take out some of these outliers that are skewing results, and this is for the data scientists to lean on the engineers and the people on the ground, right? To say, well, this data point is there because we did X, Y, and Z, right? And feeding in those maintenance actions as well, right? I topped up the oil, I changed it, I changed the filter, right? I replaced this part. How does that affect the thing? So I think, collecting all that data, both, putting sensors on and automated collection is great, but also that human action of logging the maintenance stuff is key. And then I guess if we got to that point, how, and to answer the question of the title of the panel, how does that relate to maintenance intervals, right? Or scheduling maintenance? Like, can we be that smart? I mean, Matthew talked about, hey, we have, just in time maintenance essentially with, ordering parts with, being integrated in our supply chain. How can we do that in terms of scheduling maintenance? Whoever wants to.
At the moment, that AI and machine learning is very good when you give it a specific problem and you kind of want an outcome from it. So if you've got a specific maintenance interval or something about a certain type of machine or a certain failure mode, you can set it on that, give it enough data, it will predict that, and it will be very good at that going forward. Where AI is still in development is general AI, where it has to make AI is a very conscious thing. It doesn't have a subconscious like a human. It can only work with the facts it's got. It doesn't know what other facts it needs to look for. I think when it gets cleverer than that, it can look outside the box and think, oh, I'm going to do maintenance scheduling on this. And actually, at the same time, I've got the opportunity to do it on this other component, which I'm going to take the downtime of this part of the plant being shut down, that I'm going to coordinate all these activities, and I can coordinate all the parts to come in time, and I can use it for opportunity maintenance. That's where it's going to add value that somebody might not have perceived before.
Can I also just add a couple of things? So I think, I mean, specific ways that machine learning can be used in impacting maintenance and impacting maybe also like the general condition monitoring of equipment. I think one simple thing that we can do is looking at sort of like general sensor behavior and putting together simple algorithms, right, that detect deviations, that detect anomalies, like maybe not just the static limits, right, of the high, low, but also like when is this trend developing in a way that it will eventually exceed the limits, and intervening a little bit earlier, so helping to find sort of the needle in the haystack, right? If you have thousands of sensors to monitor, of course you don't want to increase the number of alarms, but you want to make sure that they are intentional. I think another thing that can look at that, in my experience, like with equipment like heat exchangers that maybe are being that are using seawater, for example, for cooling, and there's fouling, or that the cooling medium is less effective, and so being able to detect like the performance degradation over time. So you can, I mean, if you have all of the sensors, then the best is of course if you can calculate the heat capacity and be able to look at that over time, but also to be able to like calculate virtual sensors, like sort of health indicators, right? What it should be, what you would expect it to be given all of the input parameters, and when the measured is deviating from what you expect it to be, and then putting sort of an alert on that. I think another thing with logistics is with logistics and like being able to optimize, right, and where you're storing material, how you're going to get access, or like even scheduling, right? If you have a limited number of specialists that that can solve particular problems, right? That you can optimize the scheduling so that the right person is available for the right intervention.
Awesome. So
So
we
maybe,
got 3 minutes speaking.
yeah, maybe that add a quick another real life example. So basically from like gas engines perspective, we've already seen that like machine learning is a really handy way of understanding the life cycle of the machines. And if you have like a fleet of machines, then basically that what is the like the optimal point for having the downtime and maintenance break, and what are usually really the components that will trigger this downtime, and I think that, well, working over like almost past decade with different industries, we've been able to basically like extend the life cycle of the oil for many times for many different segments. But for example, the gas engine data, it's much easier also to visualize the changes and potential changes that are coming, and I explain, and as Erik was saying earlier, that make it easy enough to understand for the people who are involved. So in that area, as an example, it's been a very handy tool for us.
Mm-hmm.
Erik, any final words on this?
Not many. To repeat what Mika said at the start, most has been said here, and I've heard very valuable stuff coming from Alexandra and Matthew as well, as a lot of other a lot of other input is needed, and I like the thought on how the labeling must be kind of generalized, right? Otherwise, it would be difficult to do this across different industries, across different technologies, etc., different models. If you don't homogenize that, then a large potential database is lost or inaccessible for everyone, so to speak, right? So I think those standards should be set.
Excellent. Everybody, thank you so much for sharing your knowledge with us. This was an awesome panel. I'm very honored to have moderated this. So thank you all for your time. Thank you for sharing. And to the attendees out there, thanks for listening.
Thank you, everybody.
Thank you very much.
Thank you.
Yeah,
Thank you.
And thank you for having us as well.
Cheers
Right.
for now. Bye.
Yes.